recall, when we are talking of conic sections, we are talking of a focus S, right? And we are talking of a directrix, a fixed line which is a directrix, and a line passing through the focus and perpendicular to the directrix is what is called the axis of symmetry. It's called the axis of symmetry, AOS, axis of symmetry of the conic section. The looks of the conic above this axis would be identical to the looks of the conic below the axis, right? And there is a moving point P such that SP by PM is going to be a constant. SP is going to be E times PM. Then P will be assuming a trajectory which is a conic. P will be assuming a trajectory which would be a conic, right? E equal to 1 gives me what? A parabola, right? E greater than 0 but less than 1 gives me what? An ellipse. And this time we will look at E greater than 1, which is of interest to us as of now, which is a hyperbola. E greater than 1 would be a hyperbola. Now, without reinventing the wheel, let me share a few things. So this SP by PM is a constant. That's the basic premise of all conic sections. Clear? Now, if you recall, while I was dealing with the standard equation of an ellipse, while we were dealing with the standard equation of an ellipse, we got something like this: x squared by a squared plus y squared by a squared into 1 minus e squared equal to 1 was the standard equation of an ellipse, right? Where e was the eccentricity and we referred b squared as a squared into 1 minus e squared, right? And what happened was, for this description, for this algebraic description, the locus turned out to be a closed curve of this kind. The locus turned out to be a closed curve of this kind with 2 foci S AE0, another one minus AE0, right? With vertices A, A0, A prime minus A0. These were the two vertices, right? And with a directrix x equal to a by e and another directrix x equal to minus a by e, right? This is what happened, isn't it? This was, now when I derived this equation, of a standard ellipse whose axis of symmetry was also the x-axis, and whose center was halfway between the two foci, the origin, whose center was halfway between the two foci and the origin, right? When we derived this equation, I just assumed SP is E times PM, and there was nothing about E being greater than 1 or E being less than 1, right? I wrote it as A squared into 1 minus E squared because I thought E was less than 1, numerically less than 1. Huh? But when somebody tells me, so this form I wrote for E lying between 0 and 1. So that 1 minus E squared does not turn out to be negative. You know? Now, when somebody tells me that, hey, E is greater than 1, if somebody tells me that E is greater than 1, the same equation will hold good. I'll have the same kind of equation, except that the format in which I would write that equation is x squared by a squared. I write it as minus of e squared minus 1. I can write this as minus of e squared minus 1 minus y squared by a squared into e squared minus 1 equal to 1. That's how I would want to rewrite this equation if e was known to be greater than 1. This is the format in which I would want to write this equation. Now in the process, what would happen if e was greater than 1? Look, if e was greater than 1, do you realize AE would be more than A by E? Yes or no? If e was greater than 1, then AE would be more than A by E, isn't it? Yes or no? That means this focus would be to the right, this directrix would be to the left. Yes or no? Then this focus would move to the right and the directrix would move to the left. Yes or no? Because A by E is smaller and AE is more. So AE would be to the right and A by E would be to the left. Yes or no? That means the same thing. This ellipse now, if E was greater than 1, how it would look? It would look like the axis of symmetry will still remain the same. It would be like now the focus is like to the right, the directrix is to the left. To the left. This is how it would happen. Right? And once again, these two vertices A and A prime are points where y becomes 0. That will not change. See? Y will become 0 here again when x is plus minus A. Right? Y is become, whether I look at this equation or I look at this equation, y is 0 in both cases when x is plus minus A. So now A would lie somewhere here, A0, and A prime would lie somewhere here, minus A0, and the focus would be, the other focus S prime in exactly the same way would be, so the other directrix would be x equal to minus A by E, and the other focus S prime would be minus AE, 0. Because AE is numerically more than A by E, right? So if I plug in a minus sign, then minus AE would be to the left and minus A by E would be to the right. Yes or no? This is how the transformation would take place, right? If E is greater than 1, see how the foci and the directrices swap positions. Relative orientation changes. Yes or no? If E was greater than 1, same equation, right? The center would still be halfway between the two foci. The center would be still halfway between the two foci. Sorry, this minus A0 will come here. You know, this would be, say, S prime minus AE0. The other vertex A prime would be minus A0. Because A would numerically lie between AE and A by E. Isn't it? So the other vertex would lie here. And halfway between these two vertices, just like the halfway between two vertices, is the same as halfway between the two foci. Halfway between the two foci would be the center of this conic section. Would be the center of this conic section, which would still be the origin. Which would still be the origin. Yes or no? Very clearly, when x is A, y is 0, A and A prime would still be points on this conic section, which is E greater than 1. Right? Right? Also notice that I could write this as x square by A squared is, so now E is greater than 1. So this is a positive number. A squared equal to 1 plus y squared by A squared into E squared minus 1. Yes or no? Or x squared is A squared plus y squared by E squared minus 1. Yes or no? Right? Do you realize? For any xy that lies on this conic section, this is greater than or equal to A squared, because this is a positive number, because E squared is greater than 1, so this is a positive number, so this is greater than or equal to A squared. That means for any point on this conic section, x squared is greater than or equal to A squared. That means x is greater than or equal to A, or x is less than or equal to minus a? Yes or no? Right? So now what happens is, x greater than or equal to a, that means the conic will exist to the right of a and the conic will exist to the left of a prime. This is what it means. That means now my conic is confined to this region. It's as if, you know, this was, the vertex comes here, the focus goes there, they interchange positions, and as if this ellipse is flipping to the right. This ellipse, this portion, say, it's as if it's getting flipped to the right. It's as if the ellipse is getting flipped. Right? That is how you can mentally imagine, conceive, right? So if it is, so imagine this to get flipped, then you would expect flipping to produce this for one portion, say, right? And for the other portion, the flipping, for this portion again, the flipping will produce this. This is what would happen if you imagine flipping taking place. Yes or no? This would be our x-axis. This is the center and also the origin. This therefore would be the y-axis. This therefore would be the y-axis. Right? This would be the looks of this conic section therefore. Right? This now, instead of calling it an ellipse, we call it a hyperbola. This would be our hyperbola. This would be our hyperbola. This would be our hyperbola. Yes or no? Now, the thing is, this hyperbola, this region is called inside of the hyperbola. This region is also called inside of the hyperbola. But other than this, that's the outside. Other than this, that's the outside of the hyperbola. That's the outside of the hyperbola. This AA prime now, instead of calling it the major axis, in this case we called it the major axis, right? But in a hyperbola, this AA prime, which is 2a, this time we call it the transverse axis of the hyperbola. We call it the transverse axis of the hyperbola. This is called the transverse axis of the hyperbola. This AA prime, which is 2a, is called the transverse axis. We'll call it TA. We'll call it TA, transverse axis of the hyperbola. Do you all understand this? And we therefore have, all that we have done is we have very effortlessly converted our ellipse into a hyperbola. We have converted our ellipse into a hyperbola without reinventing the wheel, right? So this equation, which is the standard equation of a hyperbola, we often write b squared as a squared into e squared minus 1. E squared then turns out to be b squared by a squared plus 1. 1 plus b squared by a squared is e squared. See, in an ellipse, there was, b smaller than a. But in this case, b could be smaller than a or greater than a or equal to a. It does not matter. B could be greater than a, smaller than a, or also equal to a. There is no restriction on this. There is no restriction on this. Obviously, you can see e squared is greater than 1, so e has to be greater than 1. The eccentricity, as it is often referred to as the eccentricity, 1 plus b squared by a squared. Now, so my hyperbola looks like this. This is my hyperbola, a0, a prime minus a0, one focus s, ae0, another focus s prime, minus AE 0. The origin is also the center of the hyperbola, right? Now, so the whole thing can be written as x squared by a squared minus y squared by b squared equal to 1. AA prime is called the transverse axis of the hyperbola, right? When you have this, so this tells me the transverse axis, and we take a point 0b and a point b prime, which is 0 comma minus b. Then this bb prime, they are not points on the hyperbola, by the way. They are not points on the hyperbola, right? This bb prime is called the, which is 2b, is called the conjugate axis, is called the conjugate axis, or CA. I'll tell you why. This is called, these are not points on the hyperbola, but this length, which these are points on a line perpendicular to the transverse axis and passing through the midpoint of AA prime. This is called the conjugate axis of the hyperbola. BB prime, which is 2b, is called the conjugate. A is called the semi-transverse axis. Small b is called the semi-conjugate axis. Semi-conjugate axis. Eccentricity of the hyperbola is 1 plus semi-conjugate axis squared by semi-transverse axis squared. Semi-conjugate axis squared, b squared is semi-conjugate axis squared, right? And a squared is semi-transverse axis squared. Now, see, can I remove the clutter from here? See, if I had so one thing, henceforth we'll refer to this expression x squared by a squared minus y squared by b squared minus 1 as s. S will simply be an expression, right? Like we've always done. This minus 1, we'll call it S, right? S is only an expression, right? S1 simply means, S1 is the value of S at x equal to x1 and y equal to y1. That means it's x1 squared by a squared minus y1 squared by b squared minus 1, that's S1. Like I've said, this is the inside of the hyperbola. This is the inside of the hyperbola. See, the focus will always be inside of a conic section. That's how you should remember this. The focus will always be protected inside the conic section. These are the two insides, and this portion is outside. This entire thing, this is outside. And these are called the two branches of the hyperbola. They are called the two branches of the hyperbola. The single branch of the ellipse, you know, these guys were happily residing together. Now they are daggers drawn. Right? Right? S1 is this. Let me tell you. In all other conic sections, if S1 was greater than 0, those were points outside the hyperbola of the conic section. If S1 was equal to 0 on the conic section, S1 was less than 0, it was inside. In this case, it is different. For example, C is a point outside, na? C is a point outside, 0, 0. Plug in 0, 0. You get negative. All points outside the hyperbola will give S a negative sign. That means if S1 is less than 0, then x1, y1 is outside. If S1 is less than 0, x1, y1 is outside. If S1 is greater than 0, then x1, y1 would be inside the hyperbola. I mean, for example, look at focus. AE, huh? Put x equal to AE, y equal to 0. You get a square e square minus 1, which is e square minus 1, which is greater than 0 because e square is greater than 1. So for all points inside this or this region, S1 will be greater than 0. If S1 is less than 0, then x1, y1 is outside. And if S1 is equal to 0, it's on the hyperbola, right? If S1 is equal to 0, it's on the hyperbola. It's on the hyperbola. You know what I'm saying? Now, see, do you understand? Suppose, see, x squared by a squared minus y squared by b squared equal to 1 is a hyperbola whose semi-transverse axis, STA is semi-transverse axis is A, whose SCA, semi-conjugate axis is B. This is how it looks. This is how it looks. Suppose I had something like this. Y square by b squared minus x square by a squared equal to 1. That means I have interchanged these positions, right? Then this will also be a hyperbola. In this hyperbola, A will become semi-conjugate axis and B will become semi-transverse axis. B would be semi-transverse axis, TA. A would be semi-conjugate axis. A would be semi-conjugate axis. You know what I'm saying? A would be semi-conjugate axis. Clear? This hyperbola, see, x and y have also got interchanged. This hyperbola, you know, which is in which, you know, you have swapped the semi-transverse and semi-conjugate hyperbola to get this hyperbola. That hyperbola will look like this. This will be the transverse axis and this will become the conjugate axis. This hyperbola is called the conjugate hyperbola. This hyperbola is called the conjugate. If this is called a hyperbola, this is called a conjugate hyperbola. It's conjugate. And it will look like this. It will look like this. So these two hyperbolas are conjugates of each other, with their transverse and conjugate axis interchanged, And the focus of this hyperbola, would be 0, comma BE. Instead of 0, AE, comma 0, it will be 0, comma BE. And S prime would be 0, comma minus BE would be the two foci of the conjugate hyperbola, which is this. This is the conjugate hyperbola. Sorry? This one. Yeah, sorry, this one. Sorry. This one only. I was pointing at that one, na? Goof up. Sorry. Yeah, this one is the conjugate hyperbola. And these are the two foci of this hyperbola, S and S prime. And the two directrices of this conjugate hyperbola, they would be y equal to b by e and y equal to minus b by e would be the directrices of this conjugate hyperbola, right? So all that I have done is, you know, to get the conjugate hyperbola, I just interchanged the sign. I made this negative and made this positive to get this hyperbola. Right hand side remaining the same. This is minus x squared by a squared plus y squared by b squared equal to 1 will give me the conjugate hyperbola. They are conjugates of each other. These two hyperbolas are called conjugate hyperbolas. They are conjugates of each other. They share a common center though. Right? Make sense to all of you?